Hi boys and girls. In this lesson, we're going to add and subtract mixed numbers. We're going to build on what you learned in 4th and 5th grade, and we're going to answer some word problems. We're going to use estimation because, as you know, estimation is a huge part of the 6th grade standard, and we're teaching you how to use your brains to strengthen your estimation so that you can be more efficient in answering problems on the whim, like when you are shopping for spices, just like in this problem. Go ahead and make some notes. Title it 1.4 Adding Subtracting Mixed Numbers, just like the title over there. I did 3 pages. So go ahead and pause here and make your 3 pages of notes. Let's read the scenario. All over the world, cooks use spices to add flavor to foods. Because recipe ingredients are often measured using fractions, cooking can involve operating with fractional quantities. Raina owns a spice shop in Tupelo Township. Some of her recipes are shown below. We have a recipe for spice Parisian, some spices for something called garam masala, and Betty's cake spices. These spices are measured in ounces, which means they're weighed on a little scale. In my experience, they just charge you by the ounce no matter what spice you get, and they just put all the spices in separate bags, weigh them, and you pay how many you pay in ounces. Every ounce is probably what, 99 cents maybe? I don't know, I'm not sure. I've never purchased it that way. But I'm used to using cups and tablespoons for cooking, but this is ounces, so this is interesting. So we're going to be able to answer questions here like this one. Which makes a greater amount of spice mix, Betty's cake spices recipe or garam masala recipe? How much more spice mix? So we're trying to determine which one has the most spices in weight than the other. Let's look at A1 and 2. A1, Letitia buys spices to make one batch of spice Parisian. Use estimation to decide whether she buys more or less than 4 ounces of spices. Explain your reasoning. So we're going to do that one first. I'm going to isolate it. Here's my first problem. I wrote it down. I isolated some information that is important. I'm going to look at spice Parisian, and I'm going to determine whether Letitia buys more or less than 4 ounces, and I'm going to explain it. So let's look what I did. I isolated all of the fractions, 2/5, 1 1/5, 1 1/5, and 1 1/10, 1 and 1/10, and I took it from this recipe, the spice Parisian. I took all the fifths and added them together to get 4/5, and I took the whole numbers to equal 2. And I know that that's almost 3 because 4/5 is almost close, really, really close to 5/5. So I would estimate that to be 3. But to be exact, I know that 8/10 is equivalent to 4/5. And if I add 1/10, which is this 1/10, I would get 9/10. So this is actually 1 1/10. So I took this 1/10 and added it here. And I took the 1 from here and added it to the 3. So I have 2, 4/5, and 1/10 is about 3, plus 1, and that is about 4. It's actually less than 4. So it's actually less than 4, approximately less than 4. It's exactly 3 and 9/10. So I know that she has less than 4 ounces. Here's my explanation for Letitia's purchase of spices. Letitia buys a little less than 4 ounces of spices to make spice Parisian because 2/5, 1/5, 1/5, and 1/10 is about 1, actually less than 1. And the 2 whole numbers added to that is less than 4. Let's go on to the next problem. I rewrote A2. We're going to use estimation to decide which weighs more, one batch of Betty's cake spices or one batch of garam masala. About how much more does it weigh? So there's a couple of things they want us to do. First, they want us to use estimation They want us to compare one batch of Betty's cake spices and one batch of garam masala, and they want us to know what the difference. They want us to find out what the difference is, about how much more does the one that's greater weighs. So 3 things we need to do there. So I listed all the fractions, and just by looking at it, I think, well, there are more fractions or more spices for garam masala than Betty's cake mix. And there's even a 6 versus a 4. So already I'm thinking garam masala looks like it has more spices, but we have to support that estimation or that conjecture. What I can do is estimate these to eighths. I know that half is 4/8 because all of these are eighths. I might as well go there. And 1/4 is 2/8. And then all of those, let's take 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 whole numbers. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. About 17 eighths. And there are 2 eighths in 17. So this 17 would be 2 and 1/8 plus the 9 is 11 and 1/8. What I did was I had to reduce 17 eighths to a mixed number. It's an improper fraction, and that is 2 and 1/8, because I have to divide this by 8, and I get 2 because 8 plus 8. There's 2 eighths in 17, which equals 16 with a remainder of 1. And I get 2 and 1/8, and that's 11 and 1/8. So it's about 11. I kind of cheated because I actually calculated exactly how much. So it's about 11 and 1/8. I'm going to do the same thing over here. Now I know that these two equal a whole, or 3/3. I know that these two equal 1. Then I have to take the 6 and the 2, which is 8. So that equals 9. 2 3/4 and 3/4. Okay, here's a little bar model. I marked where 2 and 3/4 is, and that's a 3. 2 and 3/4. Because we're trying to locate where that is. And we need to also add 2/3 to the 3/4. Where does it get me? So I have a little thirds here, 1/3, 2/3, 3/3, and we need to add 2/3. So I'm going to take that, and I'm going to just cut that little piece and add 2/3 to 3/4, which is about 3.5. So a little less than 3.5. This is 3.5. So if this is 2 1/3, and we add 2/3 to 3/4, it actually gets us to 3.5, because 2/3 is less than a fourth, which is what you need to get to a whole number. So together, if you were to add 2/3, it would be about 3.5. So I'm going to add the 9, the 1, and the 3.5, which is our estimation, and that'll equal 9, 10, 11, 12, 13.5. So this is about 13.5. So garam masala is greater than, has more spices, or greater than Betty's cake mix. But we need to know by how much. I'm going to estimate that if I take 11 from there, it's about 2.5. So it's about 2.5 more. 2.5 more. ounces of spice than Betty's Cake Spices. All right, here's my explanation. I had to explain. Garam masala spices, I made a mistake here, so spices, made a mistake there. So garam masala spices weigh 2 ounces more than the spices in Betty's Cake Spices because garam masala has about 13 ounces of spices and Betty's Cake Spices has about 11. 13 and a half minus 11 is 2 ounces. Now let's look at the next problem. Betty buys spices for her famous cake. How many ounces of spices does Betty buy? We need to do 3 things. Decide on an operation, find an estimate, write a number sentence, and answer it. So we're doing 3 things. The good thing about this is we already answered this problem. We know that Betty's Cake Spices is about 11 ounces. We have all of the fractions isolated. So we kind of know, we've already done the estimation. So I'm going to write that down. Okay, here's what I found. I decided on an operation, which is addition. I found the estimate, which we did earlier, so it's about 11. And then I wrote the number sentence. 1 1/8 plus 2 1/2 plus 2 5/8 plus 5/8 plus 4 1/4 equals 11 1/8. Because I converted these with common denominators, and those fractions equal 17/8, which equals 2 1/8. And then I added to all the whole numbers, and I got 11 1/8. So Betty buys 11 1/8 ounces of spices. And this number sentence is also part of my answer. Let's go on to the next problem. Okay, here's my diagram. Tevin is allergic to cinnamon. If Betty removes cinnamon from the recipe for him, how many ounces of spices does she buy? So I had to decide on an operation, find an estimate, and then write a number sentence. This is where I stopped. I know I have to subtract the 11 1/8 ounces of spices and remove the 4 1/4 ounces of cinnamon, according to the recipe on the other side over here. So this is the cinnamon. Now this is my diagram. 1/4 is larger than 1/8. Here's my number sentence, but it's not complete without the answer. This is just an expression. The answer after the equal sign completes the number sentence. So without the answer, it's really not a number sentence. So I need to subtract the 1/4 from the 1/8, and 1/4 is larger than 1/8. So I'm going to have to borrow. You should have learned this in your earlier years. You have to borrow from the whole number, and that would be 10 9/8. And then you can subtract it. 10 minus 4 is 6. And then you have to convert the 1/4 to a common denominator of 8, which we know is 2/8. Because to get from 4 to 8, you have to multiply 4 by 2, which is 8, and you have to do the same thing to the numerator. 1 times 2 is 2, so 2/8. So now we can subtract the 9/8 from the 2/8, which would equal 7/8. Here's what I have. I identified what I need to answer. How many ounces of spices does she need to buy if she removed 1/4 of the cinnamon? So without a 4 1/4 of the cinnamon, Betty buys 6 7/8 ounces of spices. And the number sentence, because I had to do a number sentence, is 11 1/8 minus 4 1/4 equals 6 7/8. Okay, let's skip to E. This is somewhat easy. We kind of did this already in this video, so I'm going to let you do this one on your own. You do that one. These two are kind of similar, but I think this one is harder. So I'll do this one. You guys do this one on your own. So I'm going to see that somewhere either in your notebook, your digital interactive notebook, and you also have to write this in your notes. Don't forget, you always have to write the problem for complete for full credit. The your turns mean I need to see you work these problems out and answer the question. So let's look at number 3. We're going to find the value of n that makes the sentence true. 2 2/3 minus n equals 1 1/4. Now we should know that there are relationships between each of these values in a number sentence. We can add, we have to do the reverse and add. We have to isolate n. This is the beginning of algebra. So 2/3, we're going to switch that to plus. Plus 1 1/4 equals n. Now I can solve it. I know that these two are 3, so I'm going to add that. 2 plus 1 is 3. And I'm going to isolate 2/3 plus 1/4. They have a common denominator of 12. I have to multiply 3 by 4 to get 12, so I have to do the same thing to the numerator. Zoom in. And that is 8/12. So 2/3 is equivalent to 8/12. And I have to convert 1/4 to 12ths. So I need to multiply 4 by 3 to get 12, and I have to do the same thing to the numerator. The answer is 8 plus 3, and we just move the denominators over. So we have 3 and 11/12. 3 and 11/12. N equals 3 and 11/12. All right, now it's your turn to do these two. There's something I want you to know before you go, and it's the word algorithm. Okay, finally, algorithm. An algorithm is a plan or a series of steps for doing computation. Each step in an algorithm should be clear and precise to describe an algorithm for finding sums and differences of fractions, including mixed numbers. So we're going to go to F2. I'm going to skip F1. Everyone has different algorithms for doing things. Your parents are going to have different algorithms than I do, and you're going to have different algorithms to solve problems for between each other. So everyone's going to have a different algorithm, and that's okay as long as there's a plan or a series of steps, and algorithm is clear and precise. No matter where you start, where you end up, if you get the correct answer and it's clear, then it's valid. So I called my son and I asked him what his algorithm was for finding the sum or difference of the fractions, including mixed numbers. So we had a conversation over the phone and I took my notes. And this is what I found out. First of all, this is actually F2, not F1. So describe a strategy for adding or subtracting fractions, including mixed numbers. So this is my algorithm. I add the whole numbers, not the numerators. I add the whole numbers. I add the whole numbers. Then I convert to common denominators to the fractions. Then I add them. And then I add the whole numbers and the fractions to get the answer. My son converts the mixed numbers into improper fractions. So he went from 1 1/2 to 3 halves. He went from 1 1/8 to 9/8. And then he converted the all of the denominators so that they're common. And then he added the numerators. Then he converted the improper fraction to a proper mixed number, and we both got the same thing. Again, we have different algorithms. We were both clear and precise, and we have a plan of steps that works for all other problems like this. We go through the same steps and plugging in different numbers. For this problem, you don't have to copy this. Do not copy this. I just want you to be familiar with an algorithm. I'll ask you about it later on. So as long as you know what an algorithm is a plan or series of steps for computation, then you're good to go. So you don't have to copy this. You don't have to copy this. You are just ending here. But I do want you to know what an algorithm is. And I want you to keep in mind the different algorithms you use to solve different problems in math. All right, everyone. Good luck. Off you go.